Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Camera Tuesday, we're gonna talk about Rode Wireless Go Generation 3, basically one step above this. So what is this Gen 3? I have no idea why the heck naming convention changed, but it changed, so it is Gen 3 now. It's just an update for Wireless Go 2 for 2025. Now, if you want to simplify, you just want like give me as quickly as possible, take Wireless Go Pro and remove time code and remove the lavalier microphone, remove the battery charging box, done. That's it. I would not be shocked if I actually opened both of them. The circuits are exactly the same. It would be much cheaper, again, from a manufacturing point of view, to like, hey, just we are mass producing it, keep mass producing it, just disable a software, basically write a new firmware, done, go home. So that's there. Now, what is the big change coming from this? Not from this, but from Gen 2. So basically, it has 32-bit float finally, which is a very big deal. Again, a lot of recorders are doing it, and in this video, I will dedicate one whole slide just what the heck is 32-bit, why it's such a big deal. It has onboard recording, meaning you can do it in something very critical, where, oh, I lost a signal, so I have to retake, and retake is not optional, possible. So in those sort of scenario, onboard recording of 32-bit, shut up, take money. USB mass storage, again, I have no idea why the heck this issue is there in Rode Wireless Go 2, and DJI fixed that in one go. Even in their DJI Mic 1, they had, hey, you have onboard storage. Connect a USB cable, tada, mass storage. Just copy paste the audio tracks. You cannot do this with it. You can open it, you can see it, you can't copy paste it. You have to go through Rode application. You have to install a Windows application in Rode Mac. You have to install an application in order to do that. Finally, they have fixed it. And it has a new charging stick, because again, they're not giving you the charging box, so they're giving you a stick. It's a cool stick, but it's a stick, and they are giving you colors. That's why I'm so damn sure that it is literally almost same hardware, seems almost same. And they're like, hey, what if you have different color plastic? Where we did not change the color of the black buttons. That mold was too expensive. But again, they have colors. Now, is that important? Again, for some people, shut up, take money. For other people, who cares? It depends where you are. Now, what about the price? The price of this puppy is set as $300, and that should translate to 35,000 rupees in India. Yes, Rode has surprisingly high tax in India, so I do not know why their prices are like, direct dollar conversion should be much lower, but it's not. It's generally very expensive, so it could be there. And compared to Wireless Go Pro, this puppy is $100 less or $50 less if these are available on sale. So this is what we are talking about. So what the heck is this 32-bit audio? Now let this be very clear. Like there are very few times when we have significant change. Like the biggest change in video industry was going from SD to HUD. That was like, whoa. Now HD to 4K is like not that whoa, because again, a point of diminishing return. 4K to 8K is like barely makes sense. So same way, audio industry was kind of sorted by 1990. Like digital audio was like, we good, we got this. And surprisingly long ago, we sorted audio. Once we had that digital audio coming through a CD, digital pipeline was sorted. However, there was always a limitation, is that on paper, 24-bit audio, like how the mathematics is done, this gives you minus 144 decibel of absolute sound pressure, meaning you should be able to represent 100% of audio possible to be decodable by human ears. That should be the case. That is mathematically, factually true. Only problem is way too many audio engineers are falling for that. It's just that that's mathematics, not real life. So in real life, you have far more limitation. Like there won't be any microphone that goes to this sort of dynamic range, and all the analog to digital converter, even though they are actual 24-bit, they do not have the cleanness. Basically, they have thermal emission and noise, meaning they have voltage, electricity, they are hot. They are not 0 Kelvin. So they have noise. So their base levels, basically majority of the bottom take 0, go down. The moment you start to reach like minus 50, minus 60, yeah, it's just noise. And how would you improve that? Well, you have to cryogenically cool it. So this idea of like, oh, it 24-bit is more than enough. No. On paper, yes, meaning if you have a clean source, you can port that audio in a computer to mathematically convert from a larger source to 24-bit, everything will be fine. But for recording, analog to digital converter does not have that sort of range where it can give you like even 144. Like if you are lucky, you will get 60 dB of clean audio. And by the time you start to push 70, 80, the background hiss will start to creep up. And if you have very subtle audio recordings, you will find very quickly it's like, bruh, I can't hear it. It's just like lost in the sea of background noise. So Mic, we generally have a microphone. That analog signal that comes out of microphone, which is generally a voltage symbol, it's very faint. We send it through what we call preamps. Now, whenever you see people talking about we are adjusting the gain, what the hell are you adjusting? Well, you are adjusting the preamp setting. Preamp amplifies it. So basically, signal comes at analog signal. No tempering has been done. It's just analog signal coming in. You just amplify it. How much you amplify it? Well, let's say it's a direct pass through. No amplification, just goes by. Again, generally would be done for microphones that are designed to capture loud noises. For example, pew pew. So you must have seen a lot of pew pew tubers. They have a very pencil-like kind of microphone. It's designed for that. So the preamp circuitry for that is like, bro, it's loud enough. Do not worry about it. It's loud enough. It will create enough strong signal. So you'll have pass through. But what if you are talking about human voices? It's very faint in comparison. So it's like, okay, then we boost it up to 20 dB. What about something even smaller? Let's say ambient sound. You boost it up by 30. It's an amplification. So then you send it to analog to digital converter. And the idea is that your microphone, how the signal is coming, how it's getting preamped, you are trying to hit the window. Basically, your converter has a sweet spot, basically not too low, basically on the lowest level, not too high because it distorts in that end also, but there is a sweet window, clean window, meaning if your audio is in this clean window, it's perfectly captured, meaning you can do any sort of post processing. It will not distort. It will not like, oh, the audio was not there, oh, like we gained it up and then it's like, oh, the noise came up there. It will be very that clean window. That's you want. That's the whole point. That's what everybody is doing. Again, you may not call it clean window. You may just like intuitively know, like, hey, audio is too low, audio is too high. What they are talking about? They are talking about capturing the most awesome, most optimum spot of the analog to digital converter. But problem is your microphone is a very analog device. It has much larger range, and your digital to analog converter, that's the limiting. Analog to digital converter is the limiting factor. And preamp, while preamp can scale anything, it's just problem is like it will trip, and there's the problem. So somebody figured the idea is like, what if you just had true preamps, meaning you take the audio signal, which is analog. It has a lot of dynamic range, almost, let's say 130, maybe 130, let's say dynamic range, decibels. So you're like, okay, send it to two preamps. One preamp, direct pass through. So basically, if loud noises are being captured by microphone, that preamp, the hot signal one, is like, I got this, no problem, no distortion. I just send the signal through, you convert it, and then you put two analog to digital converter, two preamps, two analog to digital. One preamp is set to as high gain as possible, so it can capture very faint noises without any issue, without any distortion, and then it goes to its basically two channels, two preamps, one preamp hot signal, one preamp cold signal. So cold signal gets boosted, then it goes to its own analog to digital converter, and then you merge the signal from both of them. And this is the biggest jump. We had this technology, basically having this two preamp. You could go back long in like 90s when we were recording in cassettes. There were scenarios where people like, hey, we really need to capture it. So the microphone literally had two physical circuits, and the cassettes generally have two tracks. So the idea was one track was like one gain, like physically the completely different circuit, it's lower gain, other was like higher gain, so you'll capture everything. And again, post processing at that point was like not in computers, but you can hear to it. It's like, okay, left audio is like, okay, stop it, record audio from right channel. Okay, now stop, the right channel is too quiet, now record from left channel. That's sort of been done. And even in digital, the true track safety, now in some scenarios, safety track is just a lower volume. It does not do anything. In high quality cinema grade setups, they generally had this two setups. But again, there was always two channel audio, meaning you get hot line, cold line. Awesome, does the job work? But again, it's too much post processing. Somebody came up with the idea, what if we applied mathematics? We know that what is the gain layer, so meaning we can just take this two audio systems and just like offset it. What if we compress all this data into one data stream? Cool, 32-bit data stream. Now you're like, you will hear this one word, float. Why float? Well, without floating, the audio goes from too high to too low. Problem is it will be incompatible. Unless you have a giant computer, it will be incompatible with everything. You can't play back it. So, and be mindful, you're talking about digital file that has to be played back on the devices, headphones and all that. So it's like, that's not useful. So somebody's like, hey, what if we add minus symbol? Meaning now you adjust. So you've seen the zoom when they had fader. What the heck fader was adjusting? It was adjusting where that minus symbol was. So imagine the audio level is like this, where the minus symbol is. So if minus symbol is very close to low, you're like, hey, the audio is clipping. Audio clipping is not, it's data is folded back. The minus symbol means data is folding back, and your basically NLE was like, hey, I figured it out. Oh, you want to tone it back? It just pulls the minus symbol backwards. So that's why it has above and minus. That's why float was introduced. So A, it is very easy to play back without too much mathematical hassle. And when you need to recover the audio is like always there, bro. Just move the minus symbol. So that's how we achieve this high dynamic range audio. Meaning, if you have a true quality dual data line, you do not have to adjust gain. People are like, oh, we have to adjust gain. No, it's already done. You have a microphone in, there is no gain, because again, the actual gain circuitry, that is also fine-tuned. Pass-through circuitry would be completely different for a very high amplification circuitry, and it does not need to be generic. It does not need to be like, oh, how do I do in low sounds and how do I do loud sounds? No, it's only designed for low sound. So that's why it's very fine-tuned, very tailor-made, and if done correctly, your microphone with the limiting factor. The digital circuitry won't be. Meaning, if I put in like a quality lavalier that is like multi-million-dollar lavaliers, there are some of them, and it's like audio like whoa. And if I put a crappy one, it's like whoa, not whoa. So we have sorted it. That's the biggest jump we went through in audio industry. 32-bit float is the biggest jump. I just hate that camera industry still has not figured out, hey, USB can accept 32-bit float audio directly. It's in the specification. Someday. Panasonic is making some good progress. They are like, hey, what if the camera directly absorbed 32-bit? You will no longer even need data recorders and all that. So that's there. So full dynamic range. And what if you want even higher quality? Because again, we are talking about preamps, and you are talking about one preamp that is just passed through, one preamp is too hard. So there would be a ugly kind of spot. It's like, what if you had 4 of them? Rode has like one ludicrously expensive mic that has 4 of them. Somebody sat down, is like, no, we're gonna give you a microphone that if you are not happy with the audio that is coming out of it, it's your fault. So they have like 4 preamps, fine-tuned analog to digital converters. That's it, done, go home. So that's why 32-bit audio is such a big deal. You're finally reaching a point where gain is no longer an issue. You already have a hardware level gain control where it's like, no, I will take care of hot signals, I'll take care of the cold signals. We're done, we're good. You do not adjust anything. You just give us the clean analog signal. We're done. And again, having the negative symbol means you can recover the audio and it still plays back. Meaning if your negative symbol is set too low, you are gonna hear a clipped audio, but audio file is fully intact. You're good, you can recover it. So that's why 32-bit audio is such a big jump. We went from SD to HD. Now, once you have 2 analog to digital converter, you're good. 4 is only one piece I've seen that even attempts that. But that's the whole point. Why 32-bit is such a big deal. Now, question is for whom this puppy was released. Well, anybody who wanted to upgrade from this. Basically, I'm also reaching a point where I'm happy with this recorder. It's just I'm not happy with the battery life. And so many people are like, yeah, it wears out too quickly. So for those people, it's a good thing. But here's the deal. Right now, a lot of places are selling Wireless Pro for discount prices, because again, a lot of people will be confused. It's like, hey, Rode has released something new. Wouldn't that be better? So there's a lot of sale prices. So the price gap is now only $50 in some places. Again, it could be Christmas deal or something like that, but price gap is very low. And if it's that little, might as well pay for that. You have to pay that kind of money for the charging case and all that. And again, having lavalier in some scenarios would be desirable. So might as well bite the bullet. And again, time code, it does have time code. So, or you want to get into Rode ecosystem, because while Rode, this sort of setup made a Rode kind of popular, but it was already a big deal. Rode was already a household name in audio circles, and there are a lot of podcasting gear that people are like, hey, I already have that. And Rode is like, works very well with other Rode gear. So you're like, hey, I have Rode equipment, I want to get it. And again, people do that. If you're like, hey, I have a crew that works in like, movie shootings, or they generally want to have one ecosystem. If you're like, hey, we have this crew of 3 photographers who are doing weddings, you want to make sure that all 3 have one camera system, be it Canon, be it Sony, be it Nikon, but one. So you can swap batteries, you can swap lenses, take care of each other, those sort of things. So if you want to get into that Rode ecosystem. Now, as a practical point, it's a very big thing that it has 32-bit audio recording. That means if you are taking someone's interview, even if the basically wireless signal dropped, which will happen if you go into any expo, you go into any stadiums where you have too much radio interference, it will happen. So having that onboard recording, shut up, take money. Having 32-bit, meaning you no longer even have to worry about gains and clips, and when you actually get that 32-bit file, it's like, we good, bro, we good. That's like shut up, take money. So that is a very tangible benefit compared to 2. So that's there. And they have finally listened to the people. It's like, hey, when we want to use lavalier, we want to use a locking lavalier. You do not want a lavalier that's like, yoink. You do not want that yoink. So having the locking system is, I'm genuinely shocked how the heck they released so many versions without it, but they have fixed it in this one. And clever charger and data stick. So they're like, hey, we are not giving you the pouch, basically the charging pouch, but what if we can give you a stick? Because they are using the same USB-C for charging and data. This stick, which again, it's not as simple as just like wiring it, because means that stick has a hub chip, because it's addressing 3 devices independently. So it's a complex device. I'm like, somebody spent some engineering money into this. And again, you can do firmware updates, directly copy paste data out of it. So stick is there. It's a unique thing. I'm not going to deny that's a really clever thing. So those sort of things kind of give you a good user experience. However, the case you have to buy separately, which is, I'm not comfortable with that. Now, what about DJI Mic 2, which is the closest alternative to it? Well, it's much better price to performance ratio, simply because at this point in recording, when I'm recording this basically 24 December 2024, that puppy is 36,000 rupees available in Amazon as of now. Now, I'm pretty sure Rode will cost a bit more than that, or maybe same as that. And if it costs same, this gives you case. Now, like, is the case same? No, case does come with one compromise, because they are using pogo pins to transfer energy. They can't do data transmission, meaning once you put it there, you can charge it, but you can't transmit data out of it. So that is a bit hassle, meaning if you have to do firmware update, it's like go one by one. It's tedious, but you will survive. You don't supposed to do that 24 into 7 into 360. And again, if you're one of those, you're using it as a recorder, then I can see that Rode usability will be like, yeah, I rather prefer that. So in those scenarios, go for that. But if you are mostly relying on your camera, and sometimes once in a while where it's like, oh, that time, like, the audio did drop, I do need to recover the file, those time I can see this would be like little. But again, ease of use, having a charging box, trust me, it's one of those things I've learned the hard way by using it. You want a charging box. So having charging box by default, shut up, take money. And another aspect is Sony cameras are so popular that, and again, because their hot shoe has interactive hot shoe, meaning there are a lot of data pins. They're like, what if we directly send the audio directly into your camera? Now, I do not think it's a digital data link, but it's far more cleaner, far more simpler, and it does give you far better handshake, meaning when the recording starts, then the transmitter starts and all that. So it's very good ease of use, meaning if you have a Sony camera, it does not even make sense to look into other systems. It's just like, and you're like, hey, it's just removing one cable. Trust me, you would be far more glad that you did that. So for Sony people, it's like that. And it's cheaper 32-bit option as of now. Again, if Rode undercuts it by price, that would be awesome, but I do not have that expectation. And another genuine part is that while DJI audio may be very weird for some people, everybody accepts that they have much better user interface, meaning not only that there is display, the knob is also there, meaning it's far easier to figure things out. In Rode, most things are just done by app. Here, it's like far more easier. So from DJI Mic 2 points of view, DJI Mic 2 wins, because again, as of now, when I'm making this, the price would be lower and user interface is higher, and the fact that you're getting charging box, and the fact that, again, Rode could have done that. That's why I'm so genuinely confused. It's like, what did you update? It's like, mic system. And again, Canon also has that. So Rode could have done that. It's like, hey, we support Sony, we support Canon also. Nikon also does that. Panasonic is so ahead. They're like, hey, we are doing 32-bit audio. But again, you have to buy the Panasonic's own analog to digital converter, which has direct mic connections. You can't do with wireless. But again, they are making some good progress. So this is why more people would be far more comfortable with DJI Mic 2. Again, Rode is not bad. It's just that I'm not happy without charging box. Like, no, sir, no. Colored plastic is not more important than the charging box. Thou shall always have a charging box. And again, not even improving anything major. It's just like a cut down version of Pro. So it's like very mild. So this was my presentation on Rode Wireless Go Gen 3. Hopefully you have liked it, learned from it, especially that 32-bit audio part. Hopefully in that scenario, you will click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.